Okay, so we're doing lab 7-8. We're going to start on it. We'll get through what we can today, and then I guess we are about a week behind for the semester, but I think it's possible that we may just not finish all of the labs. We'll get everything in that you need for final. But if we don't finish all the labs, I guess Dr. Shea's now teaching the first and second methods class. So basically he'll pick up next semester wherever we leave off this semester, which in the past has not been the way it was done. So that'll be a sort of an improvement. And we should be able to do the same thing with the labs.
Was that a recent change, Tom? Because
yeah.
It said online that I think Scott Clifford was teaching it or something like that, and that it was in person, or did it change to online for next semester?
Yeah, for the last several semesters, what's happened is that the graduate classes for the department have gone out, and for some reason they've reflected the 1 year ago class schedule. I don't know why that's happened. It's happened for several semesters now. Dr. Clark sent out an email with an Excel spreadsheet that has the class schedules for next semester, and it is correct. If you're seeing a class schedule for next semester in the Access UH, it's probably not correct.
I think the schedule she sent out said it was going to be Dr. Basinger face
to face. Okay. Yeah. Well, I'm not sure about that. I just I understood that Dr. Shea was teaching it next semester. In the past, it always has been Dr. Basinger, but I thought that had changed. So
I guess we'll find out.
Yeah, I guess we will. I imagine that is just an old thing, but it may be that something's changed that I don't know about. Okay, so
in the Excel sheet, she specifically mentioned in the email that Basinger wanted to do face-to-face, so that one methods class would be face-to-face.
Huh. Okay. Well, that's new. That's not what I had heard earlier, and I thought the plan was basically, hopefully that part of the plan at least will still work, because I thought the plan was to sort of pick up where we left off. But in any case, the second semester is, it starts in with regression and then moves into some slightly more complicated stuff. So actually, once you get through hypothesis testing, everything else is actually preview of next semester anyway. And then the tail end of next semester is preview of the third semester for those people that go all the way through Methods 3. So the end of the semester, the further along we get, the more preview you get, which makes next semester easier, but the next semester stands on its own anyway. So, okay, can everybody see my screen? Okay. And I was busy looking at that question 7. So I'll open the project for the labs.
We're on lab 6.
We're on the lab 7 and 8.
Oh.
Okay, and so when you open the project, you'll be in whatever folder you were in the last time you closed it. So what you'll need to do is navigate out and navigate down to lab 7 and 8, and set your working directory. And then copy that into the lab script, go ahead and open, I guess I'll start by closing what I had open. Okay, so you're going to open the file. Once you're in that directory, you're going to want to open the file that's lab08.r. And somewhere here, right after the command that clears everything out, you're going to want to, and if you have the latest version, it should have these lines right here. If you have the original version, it may not have this line. And if it doesn't, you're going to want to add it because that clears out everything in memory. And then you'll want to, right after that, put this in to set your working directory. And then go ahead and run those. So today we're going to start by looking at some data on sugar in breakfast cereals, and we're going to do some comparisons of adult and children's cereals in order to basically in order to practice hypothesis testing using t-tests. And then if we get to it, the second part of the lab is doing some more hypothesis testing using an experiment on treatment for anorexia, where they look at a couple of different treatments, and it's an experiment. So again, we'll be doing hypothesis testing, but the first is, I guess you would call observational data. It's looking at data from the real world of cereals that's not from an experiment. And then the second part is looking at data from an experiment. So to get started, if you've downloaded everything, you should have these two CSV files. And in the original version, if you've still got the original version, it's not going to be serial.csv. It's going to be serial with the parentheses 1 after it. And the same for the anorexia file. It's going to have that parentheses 1. In order for the code to run correctly, you're going to have to change the names of those. Otherwise, you're going to get errors. And I updated those names and pushed it to GitHub. If you were able to do a poll, it should be updated. But if not, just go ahead and manually change the names of those files. And to open the file, you want to use the command that's in the script. If you come over here and just click on the file and it happens to still have that parentheses 1, then it's going to create a data frame that's going to have the parentheses 1 in it. And again, you're going to get errors. So what this function or this command does is it creates a data frame named serial from that file. But we could name the data frame, and it would name it that. So it's important, one of the really important things is later on when we're going to be calling that data frame to get data out of it, this name has to be correct. So the sort of default thing is if you just open, if you use import data set, it names your data frame after the data set. And a lot of times you can get some data sets that have these really long, funky names that you don't want to work with. So that's why you want to do it this way so that you can name it something that's comfortable to work with. So the next 2 lines are to I'm going to go ahead and open this up and we'll look at the data briefly first. So there is a column called intended for, and it just tells whether this is a children's cereal or an adult cereal. So Cheerios is an adult cereal, Cinnamon Toast Crunch is for children, Cocoa Puffs is for children. I don't know about all that. I think I want Cinnamon Toast Crunch. But the next thing we're going to do is we're going to create 2 new data frames, one called children, that is a subset where it's serial, that data frame, but it's only the part where intended for equals children, and you have to do the double equal sign in order to make that work. So you run that and you get this new data set, and and all of the adult serials are gone. Then we're going to create one called adults, and it's the same thing. It's only the ones that are for adults. So the next thing we're going to do is just look at some summary statistics. And in hypothesis testing, the same as in the distributions, you know, where you're trying to find the standard deviation, you're trying to find the variance, and then you try to find the standard errors, and you try to find, you know, all of the things that you find with that. It all builds step by step, starting from, you know, one of the most important things in all of this is finding the mean. So the first thing we're going to do is we're going to find the mean for both of these, and we're also going to find the standard deviation, and we're going to create vectors out here with the mean. So this is for the children's serials. I ran this line, it created a value out here. I said vector, it's just a single value. So it's the mean. M1 is going to be children, and then S1 is the standard deviation. And you'll actually be able to see it out here in your environment.
Hey, John.
Yeah.
Yeah, like every damn lab, I renamed the file and I'm already getting errors. So I'm going to follow along and hopefully I can give you something later on.
Okay. Send me your errors, because maybe I can get some idea of why you're continuing to get errors. So if you could,
Because I just renamed them like in the actual lower quartile, you know, where it says files and everything.
yeah.
I clicked on them, renamed them, and all of a sudden it's like, nope. So I'll send you those.
Okay.
I'm getting errors too. I can't proceed. What errors are you getting specifically?
Yeah, same here.
Hold on, let me pull them up. Error in file RT cannot open, connect.
Yeah.
Huh. Okay.
I got the same error too.
I cannot open the connection in addition.
Mhm.
Okay. I'm just, since we have that many people getting the same error, I'm just going to stop. Somebody copy and paste that error to the chat.
Yeah, I can get that to you real quick.
Yeah, I guess I'll start to pile on here. For me, for the script I downloaded for Lab 8, I also have an N1 value that's 12L. Is that like one more, or?
I separated that out. Yeah, that if you're using the original script, that's going to be there. That's all that is I'll get to it. I separated it out, and I did so for a reason. So
Okay.
so-
You know what? I'm just gonna go ahead and do a git pull, and then get back while you fix the errors they're having.
Okay. Okay, so you're getting a no such file or directory. Okay, and you have your working directory set?
Yeah, yes, I do.
Okay.
I even did what you said and copied it and pasted it into the actual script as well.
Okay. Okay, so are you actually working in the root directory of C or your C drive?
I believe so, because when I open the file, I click on that. Let's see.
Okay.
Should I try opening a new
Yeah.
project?
Well, I mean, I'm gonna. Oh boy, maybe I'm not. Okay, so if you're working in the root directory of your C drive, that means that all of these files from all of these labs are going out there in that root directory, and so, and if you're also doing other documents there, then the root directory, which is just what it sounds like, it's pretty important. It's supposed to just be nothing but folders, really. is cluttered with all these files. I don't think you're actually doing that, because if you set this up as a project, it should be in a project directory. So for some reason, it thinks that your working directory is just your C drive. So can you copy and paste your set working directory command for me?
Yeah, I will. Is everybody in the group getting that same error that I posted in the chat?
No, mine's a little different. I'm able to attach serial. I was able to download it and do all that, but I can't create the subset for children and adults. It shows me an error saying this is not found.
Okay, can you copy and paste your error? And I'll look at that.
Yeah, see, for me, whenever I do the serial, I did the serial thing. It worked for me, and I could do everything. I could follow along, but it did warn me that you need to change. You'll reads in serial.cvs file. You'll need to change either C dot and then.
I'm sorry. If you've got an error, if you can copy and paste it, I'll look at it. But yeah,
no, it's fine. I can still do the lab. It still let me go on and do the lab.
Okay.
Yeah. The thing is, I'm trying to pull and rebase from Git, and it's saying that I made some changes to the R things and the labs and stuff like that. So it's asking me if I want to commit that, which I know you don't want me to do, or if I need to do something else. I guess it's a stash, or stash thing before you merge. So how do I do that?
Probably the best bet is to take the things that you changed and just save them in a separate directory for now, so that you still have them.
Lab 6 pulls 6480 lab 61R.
Unexpected 4. Okay, that error, the unexpected 4, I'm pretty sure, yeah. What's happened is somehow you've ended up with a typo in there. The actual command is, the actual name of the variable is intended with a capital I .4. And what that error is showing is intended space 4.
Yeah, I tried that too. Sorry, the intended for. I was just playing around to see if it was something that I could change, but I tried intended.4 as well, and it didn't work. It just says object intended.4 not found.
Okay.
We need to use this file for the homework too, correct? I think.
I'm not sure. I haven't looked at the next homework
Yes.
yet, but
We
possibly.
need to use this one.
Okay. So the first error, if somebody that's getting that error, if you could share with me what your command for set WD looks like.
I sent you my working directory. It's underneath. Do you want me to resend?
Oh, no, I see it. Okay.
It-
Okay. So those of you that are getting this error, are you all using OneDrive to store documents? Or is it even a mystery to you what I'm even talking about? When you get a new Windows computer, Microsoft sets you up with a OneDrive account, and rather than having you store stuff on your own computer in your documents. It has in a local directory, it wants you to push it out to their cloud service. I've had horrible. Okay. Well, okay, then Leah, could you send me what your working directory? Okay, thank you.
I sent you mine as well.
Okay. So
Even I've used, I mean, I didn't even know it was actually stored in the OneDrive, but I've used the working directory multiple times for our different labs, and I haven't had that issue.
okay. Because I have horrible luck with OneDrive. I don't even log into it. I've shut it off on my computer.
Yeah, I manually save everything, and I've also used the working directory, and it's not working for me today, and it has worked for me before.
Okay. I'll look into it. Since you are going to need to be able to use this, I'll look into it some more this afternoon. This evening. I have class this afternoon, but I'll look into it some more this evening and try to get back with everyone. But I suspect it's an issue with the working directory because for some reason, instead of, okay, so this is your, like, Elizabeth, I'm going to use yours for the example. So this is your working directory, right? So where it says, down here where it says C:/serial, it should have C:/ all of this stuff and then serial.csv.
I'm sorry, where are you seeing that?
I'm not sharing the screen. I'm sorry. So where you're in your set working directory, it's got C/users/ all of that, the whole path that's got everything. And then when it tries to open it, if you look at your error, it says C:/serial.csv. Well, before the serial.csv, it should have that whole path. So for some reason, it's not doing what it needs to do. And it looks like for all of you that are getting that error, it's doing something like that. It's not opening it's not trying to look for the file in the working directory. It's trying to look for the file somewhere else. So I don't know why it would do that. So I'm going to have to look into it. But I will look into that this afternoon or this evening, and I will see what I can find out. I'm going to go ahead and share just my screen for a second. And just to show you specifically what I'm talking about. Well, maybe I am. I guess I'm not. Okay. But we'll go ahead and go on. Actually, the suggestion that you might try, and if you want, I'll give you a minute to see if you want to do this, is come up here in the script and actually fill in the full working directory. So, like, obviously you're not going to type working directory, but if you can copy and paste your actual full working directory in there in front of the serial.csv, and then run it and see if that works.
Do I copy and paste it all the way to 8?
Yeah, you're going to want the whole thing, and there's going to need to be, it probably isn't going to put the trailing slash. You're going to need this trailing slash like that. Otherwise, because if it comes up like that, that's not going to work. But yeah, everything from the C through to that. And for those of you, if some of you on Macs are having the issue, you may not see C. You may see the little tilde. Or some of you that maybe have something, even on Windows, some of the file systems will have that. So basically copy that whole working directory in front of that and see if that helps. And if that doesn't work, the fallback option is you can come over here to import data set. This is a CSV file. You're going to go, well, I'm going to wait and see. Did that solve the problem for anyone, or?
No, for me, I put it in there and then I went ahead to test it by running serial arrow read.csv and it gave me an error again.
Okay. So the other option is this. You can come over here to import data set, and select from text base, and you'll have to come out to the directory, find the file, click open. When it opens up, you're going to want to make sure that heading is selected as yes, and that's the only change you should have to make, and then click import. And then check that this is named serial and not something else. Did that work?
Yeah, I was able to open up the data.
Okay, and it's correctly named. It's named so that it's going.
Correct, yes.
Okay.
Whenever I do that and I try to type the rest of the code, when I attach it from import dataset, it gives me more errors. So I don't know if that does that for you.
Okay.
I tried that earlier.
When you import it, underneath there's a box with the full directory and file name as it's being imported, which is easy to cut and paste. So if you click import, there's a small box with information about the file in the right-hand corner on the bottom, and it's totally cut and pasteable, and you can put it in the quotations in the code.
This file, that you're talking about here. I mean, it's not going to look exactly the same for you, but this is what you're talking about. Like it runs this command in the console.
Yeah, and you can grab that information that's between the quotes there, which is the whole information about the file.
Right.
You can grab that as you import it.
Right. Well, if it's done that successfully, I mean, that's the command. So if that command's going to work, it should already have done it. It should already have created your, but yeah, that's basically the same thing that I do whenever I set the working directory. It runs the command down here and I copy and paste the command. So yeah, but yeah,
It works.
It should look something like this, obviously with whatever your computer's path is, but file path is, but it should look something like that. Once it's imported, you should be able to do the view, and it should look like this. So if you're getting errors from this point, the possibilities are that maybe serial is capitalized or something, or that something didn't import correctly and you don't have this variable.
So Peter's suggestion worked for me.
Okay. The biggest possibility is that if you renamed this file, you may have capitalized it. And R is case sensitive, so that would, beyond that, I probably would have to have you share a screen with me so I can look at it.
So Tom, I went ahead and I did do, I can view the data and everything. It's just that when I actually go to push commands that are in the script, it just gives me error after error.
Okay. Yeah, I'm probably going to have you share a screen with me so I can get some idea of what's going on.
I'm no longer getting the errors I was before. I saved it onto my desktop as serial without the 3, and then I ran the code again and after I imported the data set manually, and it let me.
Okay.
Let
Okay.
me try that.
Okay, so I'm going to go ahead and move on with where we're at. Try to catch up here a little bit. So in this line, we're finding the means for children and adults and the standard deviations, and they're saved out here as values in the environment so you can see them. So mean for children, mean for adults, standard deviations for children, standard deviation for adults. So let's see. Peter, do the sugar contents look similar, the averages for children and adults? So that we're looking at the means, which is the M1 and the M2. Do you think there's a difference there?
You're muted.
Yeah, you're muted.
Children like sugar. They
Right.
have a lot of sugar.
Yep.
And adults tend towards lower sugar.
Yep. So that's so yeah, the children's brands have more than twice as much sugar on average. So yeah. So what about somebody else? Somebody volunteer for this one, for the standard deviations for the variance. Do you think the variance is similar?
I would say that the variance wouldn't be that similar, considering that, yeah, just I don't think it would be similar, just because the sugar means are different, so it would be the variance in
Okay.
in the samples.
Okay. Well, the variance is, the variance and the standard deviation are essentially the same measure. And yeah, they're different. It's a 2 for children and a 3.6 for adults. So we're going to look real quickly at a histogram, and I'm doing this thing again that allows us to see a single column with 2 graphs. And we're going to look at histograms for children and adults. So yeah, this is children. There's this one mode, and everything is pretty grouped around it, and it's skewed way out here. So it's got a left skew, which is backwards. It's skewed way out to the right, so it has a left skew. But for adults, there is the one big, modal point that's actually about the same as for children, but it's also fairly spread out. There are these 2 spots out here at completely different points that are half the height of the mode. So it's definitely more spread out. I guess for adults, you have, more options. There are a few options with a lot of sugar and some options with a moderate amount of sugar, and, so.
What does the sequence 0162 mean?
That is honestly, I'd have to go back through it. That's what's necessary in order to make that histogram come out, where the 16 is is putting a top value. So we're going out to 16, and then the 2 is the breaks in the frequency. So it's 2 and 4. And if there was another break, it would be at 6. So it's setting up the intervals for the column or for the X and Y axis. And every time that I try to do one of those, I have to go back and go to the help file and remember exactly how to do it. So chances are you're going to have to go back to the help file and remember exactly how to do it every time you do it. Well, maybe you won't. I do. So the next thing we're going to do is create a variable that is going to, and this is Andres in the original script. You were noticing this n. All this is creating a variable for n, which is, you know, that thing that we use when we're finding all the statistics. It's the number of observations. So we're just creating a variable for number of observations, and the variable should be 12 for each of them. And then the next thing we need to do is, in order to get the T statistics, we have to get a different a T statistic where we compare adults and children, adult serials and children's serials. We have to know the difference in means between them, and the difference in means is just M1, the mean for children's serial, minus M2, the mean for adult serial. So step by step, first we find the means for each. Then we find the difference between the means, and that difference was 6. So it appears to be a pretty big difference. You know, graphically, it appears to be a pretty big difference. The next step is we have to find the combined standard error for the 2 groups. And there's a fairly complicated formula, but it's you know, R is going to do the work for us. If you refer back to a formula sheet, you can find the formula for this. But basically all we're doing here is you can't just add the standard deviations and get the right answer. You have to take the standard deviations squared and divide it by the number of observations for the appropriate group, and then add them together and then take the square root of that. There's a reason for that. It's to do with standardization, but the thing, you know, the thing you have to remember is that there is a formula you have to use to get the combined standard error, and you need that for the next step. So we got the combined standard error, and then we can get the T statistic. It's the difference of means divided by the combined standard error. And so now we have that out here in our environment. So at this point, we've got this T statistic out here. It's a 5. Jim, do you think this is a significant difference? Okay, anybody else want to jump in? I don't think he heard me.
Seems like 5 would be a big difference if you're looking at the other ones were like 1 and 1, right?
Yeah,
So
what we would have to do is take this to a table normally. I mean, if we were doing it the old way where you did it by hand, which, you know, you can do it by hand, you'd take it to a table, and you have to know the degrees of freedom. But yeah, 5 is pretty big. If it was a Z-score, we know that's way above 2. But with T-scores, we have to know the degrees of freedom. And so there's a process that we go through to get the degrees of freedom. And again, there's a formula. If you look at the formula sheet, you can do that, and R will do the work for us, and we can get the degrees of freedom. We're working with 17.7 degrees of freedom. If you took that out to the table, you would find that that is significant. A 5 with 17 degrees of freedom is significant. In order to have R find that for us so we don't have to go to the table, you remember the Q norm, P norm, all of that we do with the normal distribution. We can do the same thing with the T distribution. And we have all the same functions. So we've got DT, QT, PT, and RT. They essentially do the same thing for the T distribution as they do for the normal distribution. And all I was doing there was just running the help files. So, question mark Q norm, which is one of the commands, brings up all of this. And then the command we're about to use is QT, and it brings up the help file for the student distribution, which is important because it shows you exactly what to do at each point. So we want to know, is this significant at the 0.05 level? Because R assumes that there's only one tail, we have to say 0.975 instead of 0.95 in the command. And the command, we have to put the degrees of freedom in, but instead of typing them in, we're going to have R get this value that we already computed. So, and it's going to tell us whether it's going to give us an answer out here, T critical. And if we want to find out if that is significant, we can use the PT command, which is similar to the P norm command that you've used before. So it's the probability with the T distribution, and we put in the T statistic that we found over here and the degrees of freedom that we found over here. Rather than just typing them in, we have it reference this. And again, because R assumes that it's a single tail, we have to multiply times 2. And we get an answer over here for P that is 4.95. That sounds like it's not significant, but you can see the E minus 0.05. It's scientific notation, so it's actually 0.0000495. I think I may have put too many zeros in there, but it is way higher than a 0.01 even. So it is significant. So we have done the significance test, and it is there. That's the long route. That's doing everything by hand. R has a function to run a t-test for you, and here's the help file. You can, like many things in R, question mark t.test. You do have to know the command name, but this goes through all of the arguments that have to go into it. And if you follow down, it describes everything. Tends to be very jargony. It may take a while to figure out, but also usually at the end of the help file are some examples. And this is probably the single most helpful part of the help files, is coming down and seeing the examples. So if we want to just run a t-test of sugar in children's cereals versus sugar in adult cereals, and this is using the subsets. We just do t-test, children's sugar, adult sugar, and we want a two-sided test, and it gives us these results. It gives us the T statistic, it gives us the degrees of freedom, and it gives us the p-value, which is the same one that we got over here, the 4.951 e to the minus 05. And it also gives us some other statistics that can sometimes be useful, but we're not concerned with right now. The other option is we can also run a t-test of, going back to the serial one, where we have the intended for that has is broken down into two types, adult and children. We can do a t-test for that file where we we're looking for a t-test of the difference in sugar, the difference in this variable based on this difference. So the tilde here is something that gets used in formulas. When you start doing regressions, you're going to see that every time. Whatever's on the left side of the equation is on the left side of that. And it indicates that there's a relationship. So here we're doing a t-test of the relationship between sugar and who the cereal is intended for. And when we run it, hopefully we get the same result, and sure enough we did. We got the 4.951 to the minus 5 again. And so we're done with that part. You know what? We've got about 12 minutes, so rather than going on to the next part, I'm going to go ahead and clear everything out. Who is still, first thing I want to do is, other than the errors, does anybody have any questions?
Yes, I just want to ask you something about the interpretation that we have before. When we have only the p-value, and so the proper interpretation for the values that we have. Because
okay.
I still mix up.
Okay.
It's like recording recode again my brain to properly interpret the results. So I know that there is significance, but it's different from the what's the difference between the T statistic and the p-value that we get?
Okay, well, the T statistic is what you use to find significance. And in order to do that, you would, I'm not sure, did the screen just change from my RStudio to my web browser? Okay,
yeah.
So in order to actually, if you weren't doing this in R, what you would do is you would take that out to a table that looks like this. And you would take the T statistic. Well, this is not the best one. Okay, yeah, it is. All right, so you would take that degrees of freedom, and we know there were 17 degrees of freedom. And then the T statistic was roughly a 5. And so we would come out here and this isn't the table I'm used to working with. So, but okay, so we're looking for a 5, and actually a 5 is so far out that it's actually off this chart, but the levels of significance are here. So here in this column, the level of significance for a one-tailed test is 0.5, so it's a coin flip level of significance. That's not significant at all. A coin flip does just as well. The marginally significant level is 0.01. No, that's not right. The marginally significant level is 0.10. That indicates there may be a relationship, but it's not something we'd normally call significant, but it might be worth looking at. 0.05 is something that we're usually satisfied with in the social sciences and in biology, so in some hard sciences as well. And then 0.01 is typically the level that satisfies people in the hard sciences in most cases. So so in this case, with 17 degrees of freedom and a value of 5, we're actually out here somewhere in the, practically talking about a complete certainty level of significance. But the other thing is to remember, as far as we're concerned, the only thing that matters, there's no such thing as less significant and more significant. It's either above 0.05 or below 0.05. And then the other thing to remember is a lower number when you get to significance, a lower number is better. You don't want to be at 0.06. You want to be at 0.05, 0.04, 0.03, some lower number.
Okay, so we always want that our p-value is lower than the t-statistic that we have, right?
It doesn't matter. We want the p-value to be 0.05 or lower. The t-statistic is just what we use to find the p-value.
Okay.
So we don't compare the t-statistic to the p-value. We use the t-statistic to find the p-value. The t-statistic, all of these numbers here, those are t-statistics. So it's not a comparison. It's not that the 2 is bigger than 0.05. It's that the 2 with 5 degrees of freedom gives a 0.05.
Okay, I get it. Okay, thank you.
And so R does all that for us when we run it, and ultimately, yeah, the only thing the T statistic does for us, and the Z statistic also, is that it finds us that that significance level. And the Z statistic's really easy because you don't have to worry about degrees of freedom. If you have enough observations, the T statistic and the Z statistic converge. So like if you have 1,000 observations, or 10,000 anyway, you can go ahead and use the Z statistic, which is based on the normal distribution. You don't have to worry about the degrees of freedom. If it's bigger than 2, you're significant.
Okay.
Right? Which is just really simple. I mean, obviously for a formal paper, you want to do more than that. But if you're in that large observation area, use the Z statistic. If it's bigger than 2, bam, you got something worth looking at, and then you can start doing the complicated stuff.
Okay.
Okay. Sure. Other questions? Okay. Everybody is free to go since labs 7 and 8 are combined. You don't have to turn anything in this week. You might want to run back through the lab worksheet, make sure you understood all the places where it asked a question, which there were only a couple, and I asked the questions during the lab. But make sure you understand those because those are the key points, and make sure you understand the progression. We start with the mean and the standard deviation and the n, and then we plug those into the formulas. We find the T statistic. If we were doing it by hand, we'd compare it to a table, and that gives us the probability. And so it's a step-by-step process. And if you understand the steps, if there's some point in there where you don't understand what the next step is, that's the place where you need to ask for help or clarification. So just break it down step by step. And that will help a lot. Anybody that doesn't have any questions is free to go. I'm going to stop sharing my screen in order to allow people who are getting errors to share their screen with me. We can take about 10 minutes or so, and maybe we could get some of that ironed out. So.
All right. Do you want me to share my screen right now, or?
Yeah, go ahead. So anybody who doesn't need help with errors, you can take off, and we'll try to get at least a couple of them ironed out. So.
Oh, you have to disable the. Or,
I have to enable it. Right. Security allow. Okay, you should be able to now. Hopefully.
Share. Okay. So I was actually able to get, I clicked over here and, imported the data set, and it actually finally actually gave me this right here, this
Okay.
area.
Okay.
But then I try to run the command for children, serial intended for children, and I just get error.
Okay. Okay. Can you click on your serial data frame in the environment?
Oh, in the environment.
Yeah. Yeah. No, that's fine. That's fine.
Oh, there.
Run the command summary. Okay, and then yeah, hit that, and then start typing INTEND. Okay, well, backspace. You got a T in there.
Oh, intended. Or just intend.
Yeah, and it's not coming up. Okay, backspace off of all of that, and go ahead and type summary. Serial, and then a $sign, and then okay. So I can tell what the deal is here. You have the exact opposite problem that Lucas was having. For some reason, in your data set, the period is missing out of that variable. So it's got intended space 4. So you can get out of that command. I know what I need to know without even doing anything from that. So if you want to go back to the script, where it says, and that's not going to work very well. Okay. Okay, first of all, put quotation marks around the intended .4. Okay, now go back and erase that period and put a space between them. I don't know if this is going to work, honestly. We may have to try something else, but we can see if this will work. Okay, now run that line.
Oh.
Okay, so what had happened is somehow that file got corrupted, and it may have been the way that it was read in. I'm not sure, but somehow that file got corrupted and the variable name was wrong. So basically, even though you didn't type anything wrong, it was essentially the same as if you had a typo.
Huh.
So you'll need to do the same thing for the next line, and then hopefully everything else will start to gel from that point on. What you could do, go ahead and run that line. Let's make sure it works.
Oh, wait, hold on. There's going to be an error right there.
Yeah.
There we go. Let's try that.
Yeah, I think that, okay.
Okay.
So go ahead and highlight everything down to the end of the end of this part of the lab.
All the way down?
Yeah, like down to just before the RM. Okay, and hit run. I just want to see if any more errors pop up for you.
Yeah. Wow.
Okay. Well, okay, but it's the same issue. If you look, you see that treatment.f not found.
For where? I'm sorry.
So
right here.
Yeah, so I'm seeing object treatment.f not found. Okay, scroll back up a little bit more. Oh wait. Oh wait, that's actually into the next part. That's actually that's actually into the next part of the lab.
So stop here.
Yeah, stop there. Yeah, so go ahead and run, go all the way back up to the top because it's kind of messed up now. So
all the way to remove.
Yeah, and run everything. Okay, so well, that didn't work. Okay, try running just the first 4 lines again.
Up here.
Yeah. Go. Okay. Oh, you weren't able to, you had to import the data, right?
Yes.
Okay, do the import data set. I'm sorry, I forgot that you had imported the data.
From up here?
Yeah.
Okay. Serial, open,
Okay.
work.
Okay. So in the script, you see where you've got that command with the very long thing? Whenever
Yeah.
so that's what should be in there instead of just the C/. And so you can actually, if you want to be able to run this script later, you can copy that. You have to be sure not to copy that little greater than sign at the beginning, because that's just going to give you an error.
So
But
is this right from users to the quotation mark at the end of CSV?
yeah.
Here, let's copy. Should I get rid of this portion right here?
Yeah, so yeah, you're going to replace, yeah.
Okay, let's try that.
Okay. So go ahead and try again running just the first 4 lines, including the RM command. And let's see.
That work?
Yeah. Yeah, the little error message you got there is not a problem. That's just because you've run this before. So it's, but yeah, that works. Okay.
And this is all the way down to here, correct?
Right.
Oh, you see that intended for is right there again.
It should work now.
Okay, let's try it.
think, but I'm not 100% sure. Yeah. Yeah. So in fact,
I got one error.
Okay. Not enough observations. That's all right. That's all right. Okay.
Oh, I didn't get an actual plot or anything over here though.
Oh, okay. Click on your, you'll have to scroll up in the environment to get the data frame, and click on the one for serial. It'll be further up. There you go.
I see, right here.
Yep. Okay, well, actually, what we have to do now is go back to the script. That period is there in the intended for now. So you'll have to go back up and fix that. You should just.
It's this one right here, right?
No, up in the third and fourth lines where we took the period out. We got to put it back now.
Oh,
because, because it's actually in there. So it was something to do with importing the data set instead of using the command. I don't know why it would do that. It shouldn't. It should be exactly the same thing, but.
Do you want me to run lines 1 through 4 once more?
Yeah, let's see what happens.
Yeah, that fixed mine.
Okay, let's try it again.
Issue.
Okay, that didn't fix yours though. You need to take the quotation marks out that we put in around intended for. They've got to come out now. So, and then try running the first 4 lines. Okay. And what I was looking at was over in the environment, you see like adults, it says 12 observations of 8 variables. The last time you ran it before we took the quotation marks out, it said 0 observations of 8 variables, which means that it had copied over the variable names, but not the observations. So so it should run now. Go ahead and run that, and you should get, there you go. You got the good histogram.
Go all the way down to.
Yeah.
Okay, let's run that. Yay!
Okay. So it wasn't typos on your part, but essentially that's what it was. It was R had sort of introduced some typos.
Oh, that's crazy.
Yeah. And yeah, see, a lot of times if I can see the screen, it's a lot easier. It's copying and pasting the code and the errors sometimes helps, but seeing the screen is just a lot easier. So, okay.
So for credit, do you want me to just send you what I have here?
Well, this is a combined lab, 7 and 8, and we haven't even gotten to 8 yet. So just go through the worksheet and make sure that you understand wherever there's a question that I asked in class, and I may not have asked all of them, but wherever there's a question, make sure you understand it.
Okay.
And you can type an answer in, but mostly I want you to make sure you go through and understand it, because that's the whole purpose here. So,
Okay. Do you want me to send you anything, or?
no, we don't. I don't need anything this week. If I want you to send anything, I will let you know next week, because it's a combined lab. So
Hopefully this doesn't happen for the next part of this lab.
well, I'll tell you that when we get to reading in that next data file, the same thing will happen, but
Okay.
you can copy that path out of the serial and copy it down in for the other one, and it should work.
Okay. Hopefully that'll do it.
And that should solve that problem. And that honestly may be something that you just have to do in the future.
Okay.
So
Should I go ahead and save this though, like this entire file?
yeah, I would, save that.
So can we go back over how that worked? Because I can't
Sure.
figure that out.
Okay. Elizabeth, do you want to stop screen sharing and then
Oh, I'm actually on a different system. I'm trying to make it work, but I can't get Zoom to function on my Mac.
Oh, okay. So what step are you at?
So I was able to change it with the intended. I took out the period, put the space, and then put quotation marks around